Alright guys, for today's lesson we're covering the first few objectives of Chapter 3, Lesson 3. So we're going to be working with quadratic functions. Just real quickly before I start, there are a few things that we're going to need to do that you might need some practice with. Maybe you can look it up on Khan Academy or something like that to look at. So one of the things that we're going to do is we're going to complete the square. Okay, and we have done this before this year when we were working with circles, but we're going to do that again today. All right, you guys, and I'm sorry, I'm writing with my finger on the computer screen. Not quite as good as on the board. We're going to factor perfect square trinomials. So factor perfect square abbreviated, trinomials abbreviated. Alright, we are going to calculate the discriminant, alright, which is going to show us the nature of solutions for a quadratic equation, and we're going to use the quadratic formula, okay? So these are all things that we're going to use that you may not have used in a while, so you might want to brush up on those. Like I said, Khan Academy is a good resource. I'll explain it as I do it. I'm just not going to spend a lot of time on it. So let's go ahead and get started. The first thing is just reviewing what a quadratic function. This is just our standard form equation. What makes it a quadratic is the fact that our highest exponent is a 2. Okay, and so there's that. We've talked about a quadratic already this year, so I don't think I need to spend a whole lot of time on that. If the a value, which is the leading coefficient, if the a value is a positive number, then our quadratic opens up right side up. And if our a value is negative, it opens upside down. Okay, also we have an absolute minimum if it's a right side up, and we have an absolute maximum if it's upside down. And then the last thing that this page talks about is our axis of symmetry. Okay, so our axis of symmetry is x equals wherever the middle line is that goes through the x value of the vertex. Okay, and so so there's that. Just a quick review. Alright, so the first thing we're going to do is we're going to take this function f of x in example 1, and we are going to take it from being in standard form like it is here, and we're going to put it in vertex form. Okay, now in order to do that, we're going to need to complete the square. Alright, so let's go ahead and look at how we complete the square. Alright, so here I have this 2, and what I'm going to do is I'm going to factor out a 2 from the first two terms. So if I do that, then I have a 2x squared divided by 2 is x squared, and then 8x divided by 2 is 2x. Excuse me, it's 4x, my apologize. Alright, so 4x. So here I've just factored out a 2. Now 5 is not divisible by 2, so I couldn't do anything there. Alright, now this is the step where we're going to complete the square. Okay, the reason that we're going to complete the square, or what completing the square, the whole point is to get a quadratic in here that we can easily factor. So complete the square, and what that means is we're going to take this two-term quadratic expression right here, and we are going to add a third term that makes it a perfect square trinomial. Okay, so here's how we're going to do that. So I have 2, alright, then I have x squared plus 4x, okay, and we're going to add a perfect square so we're going to add a perfect square which is going to be the square root times 2 as the middle term coefficient. So what that means is if our middle term here is going to be this 4, okay, 4 is the coefficient, so if we multiply 2 times the square root of 4, we're able to get that 4. So that means that I'm going to add 4 right here. So 4 is the perfect square. 4 is the perfect square that if we took its square root and multiplied by 2, we would get the 4 here. Okay? Now the x in that term comes from the square root of x squared. Okay, so you guys, this is the part where I was saying you might want to look up a perfect square trinomial and completing the square for that. Okay? Now, I can't just add 4 to this expression right here and just say, okay, well, I'm just going to add 4. It's not the same thing if I just add 4 and don't do anything. So what I did is I added 4 inside the parentheses. The 4 inside the parentheses is multiplied by 8. So what I've essentially done is I've just added 8 to this expression. So I can't just add 8 to this expression because it's no longer the same expression if I do that. So I'm going to subtract 8, okay? So I'm going to subtract 8 from the end, and that way I'm keeping everything equivalent, okay? So here's my expression here, okay? So what I'm going to do is I'm going to have 2. All right, that's my a value in vertex form. Okay, now we're going to factor this perfect square trinomial. I'm going to have the square root of my first term. Okay, I'm going to have the sine of my second term, and I'm going to have the square root of my constant, or my last term. Okay, and then I'm going to square that binomial. So this is factoring a perfect square trinomial. All right, so again, we've dealt with completing the square, perfect square trinomial, and factoring a perfect square trinomial. Okay, now here on the outside, I have plus 5 minus 8. So positive 5 minus 8 is negative 3. Okay, so here's my quadratic expression. Now it's a quadratic equation, but it's in vertex form now instead of standard form. Okay, so I'm going to transfer this over to the next page. All right, and we're going to graph these transformations. Okay, so I have I'll just bring this, make this a little bit smaller. Okay, so what I have is I have first that I am going to multiply by an a value of 2. Okay, so I multiply by a value of 2. So that's a vertical stretch. We're going to multiply from our parent function. So this is the parent. We're going to multiply by 2. So that's going to be a vertical stretch. Every y value we're going to multiply by 2. Okay, so it's going to make our function skinnier. So that's just the first transformation. So I have 0, the y-coordinate here, multiplied by 2 is still 0. Right here I had 1, 1 for the parent function. So 1 times 2, that's our y-coordinates. The x value is 1, y-coordinate is 2. Okay, over here, negative 1, 1. That's going to be negative 1, 2 when I multiply. All right, so here is my quadratic, and that's so sloppy. I wish I had the board with me. I'm sorry. But there's my quadratic when it is vertically stretched by a factor of 2. Okay. The next thing that I'm going to look at is I'm going to look at taking this skinnier function here, and when I add 2 on the inside, that means I'm going to shift my vertex in every point 2 units to the left. Okay, so this is going to be a horizontal shift. We're going to go to the left 2 units. Okay, so that's going to put the vertex at negative 2, 0. All right, and then I have up 1, up 2 over 1, and to the left 1, and up 2. Okay, So this is the same quadratic that I have here, but I've just shifted my vertex 2 units to the left. All right, 2 units left. All right, and then my last transformation is the -3. The -3 is on the outside, okay? So -3 on the outside is going to shift the vertex down. All right, so this is going to be my third and final graph, third and final transformation. So I'm going to take the vertex here that's here at -1, 0, excuse me, -2, 0, and I'm going to shift it 3 units down. So it's going to put the vertex at -2, -3, okay, and then up 2 over 1 from the vertex, up 2 over 1 from the vertex, okay? So that's got me points here at -1, -1, and -3, -1. So here is my quadratic, okay? Again, not a good picture, but this is my down 3, all right? And this is my final graph because all 3 transformations have been taken care of. Okay, so try to sketch that a little bit better on yours, but that's example 1. Okay, so you guys, I'm going to go ahead and stop this video. This is going to be video 3A. So I'm going to go ahead and stop here. We'll pick up with the next video to take care of example 2. All right.